4.2, proving and applying the sine and cosine laws for obtuse triangles. So there's proofs of both of these in your textbook. We're going to work more on this applying piece. Given what we learned in 4.1, there's a little bit of a twist when we use the sine and cosine laws, mostly in the sine law, okay, with obtuse, greater than 90 triangles. So let's jump right in here. In an obtuse triangle, angle B measures 23 degrees and its opposite side has a length of 40 centimeters. Side A is the longest side of the triangle with a length of 65 centimeters. Determine the measure of angle A to the nearest tenth of a degree, and then we're also going to determine the side length AB to the nearest tenth of a centimeter. Okay, we need to draw a diagram, but we have to be careful how we draw this diagram. First of all, it says angle B is 23 degrees and opposite it is a length of 40. Side A is the longest side with a length of 65. So because it's the longest side, a secret about triangles is the angle opposite the longest side is going to be the biggest angle. Okay, the angle opposite a short side is going to be a smaller angle. So we need to draw this triangle. We have angle B with 23 degrees. So I'm going to draw mine like this. I'm going to draw a triangle. And I'm going to just draw a triangle. You'll notice this is my biggest angle. Okay, so I'm going to put angle B here. It could have gone the other side as well. We said that this was 23 degrees. Opposite side B has a length of 40 centimeters. Okay, and then we said side A is the longest side. Well, the longest side is not this side. It's got to be this side is the longest side. And that side length has 65.0 centimeters. And what we're trying to find out first is angle A. A is opposite side A. And then eventually we're going to find this length right there, AB. Okay, so what I need to do is I need to solve this triangle. It's not a right triangle, so I can't use sine, cosine, tan. I don't know that this is a right angle. Who knows? It could be, but I don't know that for sure. Nobody told me that. Okay? So I see this and I see sine law because I have a angle and an opposite side, and I have an opposite side, and I'm trying to find out that angle. So sine law really works well into this. So the sine of angle A is equal to the ratio, of the sine of angle A over 65 centimeters is equal to sine of 23, and opposite of 23 degrees is my 40 centimeters. Okay, I want A by itself. A is what I'm trying to solve. So I am going to multiply both sides by 65 centimeters. So I get sine of A is equal to 65 centimeters times the sine of 23 divided by 40 centimeters. I don't just want A, or sine A, I just want A. So I'm going to inverse sine both sides. I'm going to get sine to the minus 1 of 65 times, I love brackets, sine of 23 over 40.0 centimeters. Okay, and now I'm going to get out my calculator and I'm going to do this work. Okay, calculator. So I'm going to work my brackets first. I'm going to go 23 sine. Okay, and I'm going to divide that by 40. Divided by 40 equals, I'm going to times that by 65. Okay, and I'm going to be doing the inverse sine. Whoops. A equals sine to the minus 1 of, let me look at that number, it was 0.6349. Okay, and I got this when I inverse signed it. So you're looking for, sometimes you press second sign or you're looking for a button that looks like this. I got 39.4 degrees. Okay, last chapter, chapter 3, when we get this answer, we'd say done, wash our hands of it. But I want you to look at this triangle right here. Does that make sense that that angle is only 39 degrees? It does not make sense. There's no way that that is just 39 degrees. That is much bigger than 39. So the sine law has led us a little bit astray. It has told us that um, this angle is 39, but it's not. So we have to use what we learned in section 4.1, and that is that we knew that the sine of any angle is equal to the sine of 180 minus that angle. Oops, minus that angle. So really, we got 39, but what we're going to do is we're going to go 180 minus 39.4, and we get 180 minus 39.4, we get 140.6, and that makes a lot more sense. So why that led us astray is if we took out our calculator and if we did the sine of 140.6, we press equals, come on calculator, sine, there we go. Look, we got that 6349. Okay, I'll show you that again. It got 0.6347. Anyways, that was my rounding. It got the same number. Okay, so our calculator always defaults and says, well, you're looking for that smallest angle. But really, the ratio of the sine of 39.4 is the same as the sine of 140.6. Same thing. Our calculator didn't know which one we were asking for, so we had to use our brains and we had to say, you know what, this was really looking for the obtuse angle, that 140.6. Okay, so when you're doing questions in this section, every time you use the sine law, you have to be careful. You have to say, did it give me the answer I was looking for? Look in the answer book. If you got the wrong number, do a quick check. Is 180 minus your answer the correct answer? Then that's what you forgot to do. Okay, so just something to check in on. Next part of this question says determine the side length AB. So this was our angle right here. Now we're trying to find this length right here. So I still want to use the sine law. I always need to know the angle opposite. Well, I can figure out this angle now because I know that the angles of a triangle add up to 180. So I can go 180 minus 140.6 minus 23. I can get out my calculator. I can do that. And I will do that if I can find my calculator. And I get 16.4. Okay, so I have 16.4 degrees here. And now I can use the sine law to solve this. Okay, so I'm going to set it up. I'm going to use the numbers I was given. I'm going to say the sine of 23. That's always a good tip, is to use the numbers you're given in a problem whenever you have a multi-part question. In case you made a mistake, then you're only using the numbers that you're given, as opposed to the numbers you derived where you could have made a mistake. So the ratio of the sine of 23 to 40 is the same as the sine of 16.4 is to length AB. We're going to cross multiply. We get AB times the sine of 23 is equal to 40.0 centimeters times the sine of 16.4. Dividing both sides by the sine of 23, we get the side length AB equal to 40.0 centimeters times the sine of 16.4, all divided by the sine of 23. I'm going to get out my calculator. I'm going to plug that in. So plugging that in, just the way on my calculator I have to do this, I have to go 16.4 sine, and some people can go sine 16.4. I'm multiplying that by 40, and then I am dividing that, where's my dividing on here? I'm dividing that by the sine of 23. So I need to do some brackets here, divided by 23, and then sine bracket equals So I get 28.9. Oops. 28.9 centimeters. So getting to know your calculator after chapter 3, you should know your calculator, the order you put it in. So that's how we found the length AB. Okay? Moving on to our next question. Now we're going to use reasoning and the cosine law to determine the measure of an obtuse angle. So we have the roof of a house contains two slanted sections as shown. A roofing cap is being made to fit the crown of the roof where the two slanted sections meet. Determine the measure of the angle needed for the roofing cap to the nearest tenth of a degree. So they're trying to put a cap on the roof so that no rain comes in. Good idea. So let's just redraw this triangle. So we have a base of 33.5 feet. We have, this is 20.3 feet. And this is 17.0 feet. So not really a symmetric house here. Okay, what we're going to do is, the first thing we know is that the largest angle is going to be right here. This angle is going to be the largest because it's opposite that largest side. So that's going to be a large angle, just to be aware of that. So maybe when we get an answer, we might have to think about this. We know all the side lengths, so what I'm going to do is I'm going to use the cosine law. And the cosine law says, and we can use any letters, but it says that c squared is equal to a squared plus b squared minus 2ab cos of c. All that matters is whatever side length I put here, I need to have the angle opposite that side length there. So the angle I'm trying to find is right here, so the side length I must put here has to be this 33.5. Okay, so I'm going to put 33.5 squared is equal to, and A and B, it doesn't matter which one I put where, it just needs to be the other two sides. So 17.0 squared plus 20.3 squared minus 2 times 17 times 20.3, I'm running out of space, all times the cos of theta. And I'm trying to get theta by itself. The angle is what I'm trying to figure out. So I need to do some math to get that all by itself. First thing I'm going to do is I'm going to move these two over to the other side. So I'm going to start that over here. I'm going to have 33.5 squared. I'm going to subtract 17.0 squared from both sides. I'm going to subtract 20.3 squared from both sides, and I'm left with negative 2 times 17 times 20.3 times cos of theta. Okay, now I'm going to divide both sides by negative 2 times 17 times 20.3. Okay, so dividing both sides by negative 2 times 17 times 20.3. So I'm dividing this by negative 2 times 17 times 20.3. These cancel out, cancel out, cancel out. So I'm left with just the cos of theta. So 33.5 squared minus 17.0 squared minus 20.3 squared, all divided by negative 2 times 17 times 20.3 is equal to cos of theta. So then we're going to have to inverse cos this when we're done. So this is just a matter of entering this all into your calculator, being careful with brackets, and we should get that the cos of theta, simplifying, we should get this to be 421.16 on the top, and we should get negative 690.2 on the bottom. Okay, so it'd be a good idea to pause, take out your calculator, make sure you can get that same answer. We're going to inverse cos both sides. So that's when we do our cos to the minus 1. And we inverse cos, so that crosses out, and we get our angle to be 127.6 degrees. Okay, so let's Think about this. Let's look back at our diagram. Does it make sense that 123 degrees could be right here? That a big angle could be across from a big side? Of course, that does make sense. So we did get the correct answer with the cosine law. A little summary right here that is found on page 170, which will be very valuable as you work through this section. The sine law and the cosine law can be used to determine unknown side lengths and angle measures in obtuse triangles. The sine law are used in the same way that they are used with acute triangles. If you know when to use a sine law, if you know the lengths of two sides and an angle that is opposite of one of them, then you're going to need to use the sine law. If you know two angles and the length of any side, you can use the sine law. Cosine law, if you know two sides and as long as one of those angles is contained, use the cosine law. Or if you know all three sides, use the cosine law. A little bit of a warning, be careful when using the sine law to determine the measure of an angle. The inverse sine of a ratio always gives you an acute angle. Remember, it spit out as that 36 when it really meant 140, or rather 39 when it really meant 140. So it always, your calculator is always going to give you the acute angle, but the supplementary, or 180 minus that angle, has the same ratio. You must decide whether you're using the angle it gave you or 180 minus that. So you always have to use a little bit of critical thinking by looking at your diagram. Because the cosine ratios for an angle and its supplement are not equal, remember we saw that the cos of 150 is equal to negative the cos of 30. Remember, they weren't exactly equal. Because of that, the measures of angles determined using the cosine law are always correct. So when you use the cosine law, no stress. You don't have to think about it. It's going to give you that right answer for an angle. Okay, the other thing I just want to add to remember is that the longest side of a triangle is always opposite the biggest angle. That's another thing that's important to remember. So try out these practice questions.